and understand that these are questions to expect on the read. The first one's 2 points, the second one's 4. There is some latitude in the answers themselves in terms of what's going to earn you credit and what doesn't. Looking at what's there for the first one, who can tell me what you'd have to go through and do to show that those two were the same thing? What would you go through and state? What do you want to say?
Well, first you'd multiply the exponents.
Okay. So what did you have then when you did that?
3 to 2 fifths.
Okay.
And then it can be rewritten as a root. So it would be what's the fifth root to 3 squared. Not 50, that's 3 squared.
And then what, you got to make this connection though, but what is, because as of right now, you've gotten to here, you have not shown that they're equivalent yet.
Well, you'd square 3 and then fifth root of 9.
You have to get to this point. It's telling you what to get to. If you had stopped where you were, even though you're right, you get 1/2 of the credit. Okay? Now, did we have anyone that viewed it a different way? Because the state's rubric did not do it the way that I teach it. Doesn't mean that the way that we're doing it by doing it wrong either. Did you have another way?
Well, it's basically the same thing because I did 3 and then raised it to 2, and then I did 3 squared, which is 9, and then I did 4.
Yeah, that works. What they're trying... That would, then you have to connect it though and say you're taking the square of the radicand. Okay, if you make that connection, yes. Here's what the state's rubric says. Now understand there's a thing called local latitude, which means you can grade it. As long as the math is appropriate, you're good. The state wants you to see this, and I thought we even talked about it last time we had class. Can those exponents switch positions, yes or no? Because when you have a power to a power, what operation's getting done? What'd you say? Multiplication. What do you know about multiplication? It is what? Commutative. So does the order matter with multiplication? No. So they said take it as 3 squared to the 1/5 or 9 to the 1/5 and then write that way. I think, in all honesty, the way that we were told in the beginning is the best way to do it. You've got to recognize power to a power. You've got this to the 2/5 power. What does the numerator represent? Power. The 5 represents the root. Make sure you make this. By the way, does anybody know what this is called? Up in front, the 5 has a name when it's sitting out on a ledge of a radical. Now, it is a root, but there's another word that we use to describe it, just the 5 itself. It's your index. Okay? So in any case, this is the big one. Now, if you didn't do what you said, which is convert it to a single power, if you didn't mention the commutative property that's half credit, your way of doing it would have gotten you full because you condensed and then evaluated. Same thing. If you don't, though, show me that 3 squared is 9, that's going to lose you 1 point. You have to give as airtight of an explanation as you can. Questions on that one? Now, this was only 2 points, so hopefully it's very easy. The next one up, when we do this one out, is more interesting. We've got to algebraically find the zeros and then go through and graph this. So looking at what's there, what's our first step? Let's handle the tough part in the beginning. What do you have to do to algebraically find the zeros? Cassie, what would you have to show out? We have to do something before we factor it. Set the function itself, that p of x is 0. Now, what kind of factoring are you going to have to do? Who remembers what that's called? Grouping, yeah. Technically, what you're doing is a triple GCF. Look at the first 2. What can you factor out from the first 2? And second 2? So that leaves me with this. And now, what can you factor out from here? You did 2 GCFs. You're not done. What's the third GCF, Alexis, that you can go through and take? Looking at this, right? 2 halves here and here. What do those 2 halves share? X plus 1. And when you take that out, what are you left with? So far, she's right. What would we do from here, Alexa? So what are you going to write it as? What do we do now from here? Amanda? What are they called? Those are tractors? There you go. So you would go through, and this I love too, because the state didn't take off for this. For I told them when we're grading, I said, put my kids' Regents questions to the side. Because if this step is not shown, they're losing a point. I don't care what the rubric says. You cannot make this assumption. You need to show me this. X plus 2 equals 0, x minus 2 equals 0, and x plus 1 is equal to 0. So how many zeros does this have? 3. How many times is this going to cross the x-axis? 3 times. At what values will it cross the x-axis? Why? What now? You can go through and give the graph. Why would I be so disappointed if that was the graph you gave me? This would lose points on every test or quiz you take in here. If it's done within these 4 walls, this is losing points. This needs to go up further, number 1. And some people are doing like this. You give the points, you say, yeah, it goes like this. Close enough isn't close enough. Now, there's something else that's missing on here. What is so offensive about this? You got to label it. And you could shorten, you gave almost too much. I just throw this on here. This is give x, because it defines it in the question. Okay. Didn't we say that the other day? Like literally, didn't I sit here and yell for like 3 minutes? Include the table over and over again? Raise your hand if you gave me a table. Thank you. If you didn't, write on your paper. T-A-B-L-E. How many points can you fit? 6. So how many got to be on the table? 6. Not 20. Someone in the first class goes to look out MIT with this question. But then I've got to list out 20 points. No, you don't. How many fit? 6. That's it. You know why we let you go through and take unimportant classes like art? So you can at least apply it right here and give me beautiful graphs. That's it. If the math department didn't need you to graph, we wouldn't even have an art department in the building. We'd say, never mind, get rid of it. Not really. But it makes sense. The other goes that way. Now, things that I want to make sure you have there. Did you give me a nub? -2. Did you give me a table? -2. And they're like, so if I didn't give any of that, I'd lose 4 points even with all that work? Sure. How old are you people? 16? You can't copy numbers from a table and put dots on a paper? 15? Is anyone in here 30? Okay. You're all over 14, is that correct? Okay. Is anyone in here the learner's permit? Yeah. 1 person, 2. Okay. You're old enough to drive a 2,000-pound vehicle at 65 miles an hour. Is it too much of me to ask you to throw a table on there? No. Please. It's so difficult. It's difficult about everything. Now, these were actual Regents questions. When I'm looking at the item analysis at the end of the year, how many points out of 6 should I see for everyone across the board? 6. I liked, Ben, did you say 7? He's saying that you're going to do so well that we're going to give you extra credit. Even though extra credit doesn't exist. That's how outstanding you're going to do. And he's right. Get the 7 points, not the 6. I was sitting there the other day. We had a meeting, so I had to deal with the people from Thomas. We're standing there, and the lady from Thomas is going, my Enriched kids can't do this. They can't do this. Already making excuses. You sound like a loser. I sit there, and I'm getting so happy. Because you know what? I don't want you just to beat them. I want you to beat them by at least, I want our class average at a minimum to be 5 points higher than theirs. 5. I want them to huddle up with those Thomas Algebra 2 teachers at the end of the year. Bring them all in and say, listen, we thought you were doing well. But then we saw those kids from Schrader. You all did so terrible that we're firing every one of you. And we're going to make McAtee teach 7 classes over here and 7 over at Schrader. Because his class average was 5 points higher than yours. 5. At a minimum. Your grade was like 10. My favorite was the one year that my region students scored higher than the Enriched kids in this building. I sat there, and then at the meeting, and they go, "What happened? Did you do?" And I go, "Oh, my kids weren't the Enriched ones? Oh, okay. I'm sorry, I thought I had Enriched kids." There's something special about those work ethic. And the other thing is, if we do it once, I don't make the mistake now. Make the mistake now. When don't you want to make the mistake? Reach. If I'm sitting there, if you're looking at that right now, and you're going, "My graph doesn't look like that," can you make it look like that in June? Can you make it look like that tomorrow? Suppose. Try. Who here takes art? Do they teach you how to go through and draw wonderful graphs? Do they say, "Graph out today, we're going to graph P of X, we're going to use watercolors today"? No, that's not how it works. Maybe I'll set my own art class. So we're going to graph logs today using oil paints. Is that something you don't even use paints? You just, hand sketch? You use computer? That's cheap. Now, what I need you all to do is this. We left off last time we had class. Make sure that you signed into your calculators if you haven't already. We're left off. By the way, take a look at the day checklist on the front of your notes. I love signing into your calculators if you haven't already. It's only been 100 days to get. No, we have 70 days left. We have at least 60 days together. So sign into your calculator for the 60th time. Now, the stuff we're doing today, we're going to use the calculator to check what we're doing in some computations. Take a look, loves, at question number 1. Why would you want to lean over, and by the way, check off what today's date is. Today is the 19th. What question, or what thing is this on the 19th here? Hang on. What day are we getting done today? Day 4? Uh-oh. Day 5, 6, 7, 8, the test. Be ready. Why am I going to high-five the person next to me if I see question number 1? Why would you? Oh, so easy. So easy. You can tell me why it's so easy. One person, 3, 4, 5 of us. What? How'd you know it was x equals 3? You're missing a step. 2 to the x is equal to 2 to the third, so x is equal to 3. You don't need a calculator to check that. Take a look now at the next one. Let's look down at number 3. Why are you going to go, "Oh, 3, it's impossible"? Why is 3 more difficult than 1? Hands up, please, if you can tell me. What makes 3 more difficult than 1? We got 1, 2, 3, 4, 5, 6. Look at 3, look at 1. Why is 3 more difficult than 1? Okay. You can't establish a common base. Who remembers what we would do if you can't establish a common base? Let's rewrite this in log notation. By the way, make sure you've isolated the base exponent. That's very important. So go into your, I'd advise this. To start off all of these questions, you go in and I would highlight, or I can highlight, you circle. Circle the base and the exponent. Do we have that alone? And our answer is yes. Now, what is this going to look like when I write it in log form? Hands up, please, if you can tell me. Well, and this shows me. And yes, I do yell about it because it's day 4 of this unit, and we did it on day 1. If you don't know your log conversion, it's going to be very tough for you to be successful. And yes, it may mean you've got to go back and do more of the questions that we skipped over previously. We got 1, 2, 3, 4, 5, 6, 7, what? Yep. And she said it perfectly as well. It reads going across, because that's another thing I was complaining in the other group to the calculus students about you all. I was going, they think it's cute when they don't know how to say log 27. No, that's 27. Log low 2, high 7? That's odd. You wouldn't, think about like at Harvard, when they're explaining this to their students. They're going to go, yes, this is log low 2, high 7. And then the other one was it's 2 to the 7. No, because that would look like this. Log of 2 to the 7th. Are those the same things? No. Now, what can we do to get an answer now? Hands up, please, can you tell me? Whoever gets this one, there's big consequences for getting this answer. Big. No, what do you want to say? What can we do to get our answer? Yeah, absolutely. That's why you got it. Because you sit there, but the good thing is, I'm assuming when you were doing that, you're trying to go through and say 2 to this power gives me 7. By the way, the answer is going to be between what numbers? Hands up, please. Without going into a calculator. Your answer is going to be between what 2 numbers? We got 3 people? Come on. Your answer is going to be between what 2 numbers? Luke, which 2 numbers? Why? And 2 to the second is? And our number is? 7. Go into your calculator and type this in. Now, Noah, you tell me how many places after the decimal are we going to be rounding to today? 2. 2, all right. Go into your calculators, love. Make sure you've signed in if you haven't already. Go into your calculators. Get out a scratch pad if you're in it. So, 2 places, 2.81, is that right? Yes or no? Okay. How can we check our answers? And this is where it gets frustrating. There's so many ways. What's one way? Yeah. You can use the numeric solver on it. So go, is it menu or doc? I think menu 3.1. Type in the equation, put a comma x after it. Go through and do that right now. Nope, don't do that. Type in the original. 2 to the x is equal to 7. Comma x. Tell it what to solve for. And enter. Did that? Oh, no. Go back. Just put comma x because it's going to come up with the answer right now. Press enter. Now, that solved it. You've got another way of doing this, and that's to write in an equation. So do out 2 to the x power equals 7, then do a bar, and then do x equals, and select this whole mess up here. Not an approximate value. Careful. 2 to the x equals not x, but 7. And then do x equals and select that mess up top. The whole thing. Press enter. Is that true or false? If you use a rounded answer, it's going to be false, by the way. The other way of checking it is this. Do out 2 raised to the x, and then don't put an equal sign, put a bar there, because you're going to evaluate out the expression at x equals 2.8 and some change. Select that mess. What does it come out to be? 7. There's literally 3 different ways you can check every question. 3. I need you to do one of them. Questions on that? Now, and by the way, the kids at Thomas don't know about numeric solve. They have this little section. Does anyone have a technology tip that they want to share? In my head, I'm thinking, boy, you've got a leg up on them. They sit there and all they say is, these calculators are stupid. Good. Good. Keep thinking that. Keep thinking it. Do you know how to check your answers in the calculator? I don't know. Good.
You know how to spell the ridge?
They're going to be very good at that, aren't they? They're going to get an A+ at failing the read. And hopefully you get an F at failing the read. Take a look at the next one. We're going to pop down to number 7. First thing you need to do is isolate the base and exponent. You're trying to get alone because the variable's way up high. Let's highlight that. Circle it on your paper right now. Who can tell me what's the base and the exponent I'm looking to get alone? We got 2 people. Come on. What? You're absolutely right. E to the negative x. So let's go in. We're going to select this. Now, we're going to take all of our steps to get that alone first. What would you do from here, Eli, to get that alone? So I've got 5e to the negative x is equal to how much? Negative 3. What's our next step going to be? Christina? So e to the negative x is equal to 3 over 5, 4.6. It doesn't matter. From here, what do you do next? Can you get a common base? Let's ask that right away. Is there a common base? Well, you can tell me what we're doing from here. There's actually more than one step, by the way. 1, 2 of you, 3, 4. Erica, what do you want to say? No, we can keep that as it is.
Of 3/5
Now, who sees something? You can sit and don't yell at it. Do not yell at me. What? What's that? You could, if you wanted to make this bigger, you could write it out as, and we'll do that in the calculator part. You could do log base e of 3 minus log base e of 5 if you wanted to. But you could also do the natural log of 3/5 is equal to negative x. In either case, and I mean, the calculator has rendered some of this obsolete. This, really, if you just know to use a log every time, you're good. This natural log stuff comes up in calc form, which you should see, but log base e is the same as natural log. It doesn't matter. They're interchangeable. They're going to give you the same thing. What do we get when we type that in? Or I'll say this. We type that in, and then what do we have to do to get our answer? Leah? No, divided by what you said?
0.
No.
1.
Divided by what?
-1.
-1, I don't know if we set the negative or not. So, go into your calculators, loves, right now and do this. Let's do it out in one statement. Do control division. The numerator you're going to write out at. Then let's do out log base e of 3/5, and then we're going to divide that by -1. Log base e of 3/5 divided by -1. Do it all at one step. Boom. Go in right now, please, and do control division. Natural log of 3/5. Natural log is control e to the x. What do you notice about those answers? How can we check our answer? Go back into the original. Actually, let's do this. Plug in the left half of the equation. So, do -5 times e raised to the negative x plus 9, and then put a bar after it, and do x equals, and select that mess from up top. What do we get? 6. What did the equation say it should equal? 6. What's our answer to the 100th position, which is what we're going to round to all day? What is that going to come out to be, loves? I'm saying, what's that? 0.51? Okay. Can you do n solve on that? Yes or no? Yes. Next one up. And here we go, because you've got to be a problem solver. You know how to solve 1 already, whether you know it or not. You know how to do number 1 already. Hands up, please, when you can tell me what you're going to do to solve out number 1. We got 1 person, thank you. 2, thank you. 3, process what's given. 1, 2, 5 of us. Come on, we're better than this. 6, 7. We were asking, this question came up in the other class, and they're like, what's the worst? Some of you, our approach to problem solving is, you're so nervous. It's almost as if like there's a trap door underneath your desk, and like if you get the question wrong, I hit some button, and it opens up and you get like dropped into some fiery pit like in the movies. I don't want to ruin it. Take a look at the ground right now under your desk. Is there a trap door there? There will be next week, but there's not yet this week. It's getting installed over the weekend. Now, what are we going to do to get this answer out? What do you want to say? Perfect. Let's exponentiate it. So, what's that going to give you when you exponentiate it? What do we do from here? John Paul, what's next? Subtract 1. Divide by 3, you get x is equal to what? No rounding necessary. Now go back into your calculator. Let's try this as a numeric. Let's try this as a numeric solve. Let's see what it gives us. Because remember, the calculator gets all weird when it comes to end solve, and it gets weird when it works with log. So go in right now, 3-1 for numeric solve. Plug in the original equation, the original. So log base 5 of the quantity 3x plus 1 equals, is it equals 2? With comma x. Hit enter. Did we do it right? Did anyone's calculator give them the yellow triangle on this? It's interesting because it doesn't always do it. Some people's calculators will literally work and some won't. We'll see it in later examples. We did this correct though. Take a look now at number 2. How is 2 different than 1? Let's start off with that. Hands up please if you can tell me how 2, and this would be a great question on a detective exam. We got 1, 2, 3, 4 of us. Get real. 5. How is number 2 different than number 1? It's a log set equal to a log. Now, does anyone want to guess as to what you do to solve out number? I know it's a big, and again, the trapdoors aren't in this week. What do you want to go through and do to solve it out? Do you remember what those are called? Does anyone recall what the name of those are? Yeah, set the arguments equal, okay? So we've got 5x minus 1 is equal to x plus 7. You've got, and he said it perfectly because you have the same log with the same base. So if the left and the right side are equal, we're going to solve this out. Normally we do letters to the left and numbers to the right, so I'm going to subtract an x and add a 1. So I would get 4x is equal to 8, which means x is equal to 2. What do we know, by the way, about the argument of a logarithm? We put a constraint on it last time. Do you remember? Absolutely right. Our argument has to be greater than 0. Plug this in. What's 5 times 2? Minus 1. So this leaves me log, if you need to see it, log base 3 of 9 is equal to, what's 2 plus 7? Okay, are they equal to each other? Yes or no? Did you need a calculator to check that, or do you have a brain? Some of us are smarter than the plastic. Let's hope. Let's hope. How is 3 different than the first 2? Because our approach is going to be a little different. How is 3 different? 2 logs on the same side. Someone said before, can we subtract over one of those logs and set them equal to each other? Watch what happens, because we're going to erase in a second. This is the log of 5x, then is equal to 2 minus the log of x plus minus 1. Why can't I set the arguments equal right now? Why can't I set the arguments equal right now? Because of that 2. So I'm going to get rid of that. Can anybody tell me what step you want to take? And I love, you act like this is something new. The skills that we've done so far, you already know how to do this. You just are apprehensive to. We got 3 people who can tell me what we do to start it off? No, because we're not going to do that. We're not going to set it equal to 0. at this right-hand side here. When you have two logs multiplied together, when you have two logs added together, what can you do to both of those logs? So this is going to become the log of 5x times x minus 1, and that's going to have to equal 2. Now, which type of question does this match up with that you've done before? This starts to look like what number question that you've done on this page. Seriously? Which question is this going to be solved like that you've already done? Eli? 1. Except something's not written in. Luke, what's not written in? What's the base? Okay? What would this be if we wrote it out in exponential form then? Distribute that out. What would you have? Alex V, what's next? What do you get? Right now we go on autopilot. What kind of equation is this going to be, Talia? Quadratic. How many answers do quad equations have? What are you going to do to get those answers? Now, she's going beyond what I was expecting. We're going to set it equal to 0 to start. 5x squared minus 5x minus 100. Now, she identified this has a GCF of what? 5. So I'm going to take that out. It doesn't go away. That leaves with x squared minus x minus 20. And hopefully you don't need a calculator for that. What do you do now? 2 people? 3? 4? Robbie, what do you think? Mm-hmm. What's it going to factor down to? Who's mad right now? Do you see what? Forgot the 5 in front. How many factors does this have? Hands up, please, if you can tell me. How many factors will this have? Christina? Careful. 3. We've got a set. Now, you're going to sit here and probably argue with me. Something about this is odd, though. Yeah, that's just because it's a multiplier. Go back and check both of those. I'll say this. You shouldn't even need to plug them into the calculator. You know right away that one of these is not going to work. Hands up, please, and tell me which answer you know right now will not work. You don't need a piece of plastic to tell you this. Which answer should you not get? Abby? Why? Close. That's not sufficient. We can get negative answers. X can come out to be negative 100 if we wanted to. It depends on something else. The what of the log? What? The argument's going to be negative. When you plug that in, and by the way, you should even see, those of you who are really strong math students and strong algebraically, why did this answer come out? Look back at the original. This would be 5 times negative 4. So this argument is negative. We've got negative 4 minus 1. That's negative 5. So that argument's negative. And when you multiply them, what do you get? Positive. That's where extraneous solutions come from. Now, the reason that it's a little bit of a misnomer to go through and state we're going to reject for a negative is this. I like to put in questions. Who can give me a positive x value that we can't have? Who can tell me a value, a positive value that we wouldn't be able to get as the answer? Evan? 3. So x can't be equal to 3 or 4, 5 or 6 or 7. Why can't x equal those values? What happens at Karen? Yeah, causes our argument to be negative. Now, This is another one. And questions on what we've got so far. You could check those, but that's going to reject. Take a look at number 4. Looking at number 4, loves, what do you think you'd want to try in 4? You tell me. What do you want to try? Because there's a problem that's going to encounter. We'll take the path that you tell me. Nick, what do you want to do?
You multiply the x.
Yeah, and can anyone tell me why I wouldn't put the other one of the natural logs and move it to the other side and then set the arguments equal? Does anybody know why that wouldn't work? Negative natural log, yeah. So let's condense this down, and it would be the natural log of, now, what are you putting, what is the product of those two when you multiply them together?
X squared minus 2x.
Okay? So we get to this point here. What's next? Yeah, you know what you do from here?
And we rewrite it to e to the 0 equals x to the
Now, she's absolutely right. Some of you start going, oh, how can I solve that? That has an e in it. Oh. And again, as we do this, there's so much beauty in this because things start simplifying out. I mean, things start happening. Situations that look really complicated, if you persevere through, you're going to make it out on the other end just fine. What type of equation is this going to be? Quadratic. We set them equal to 0 and solve. So this is the first time that you're going to face some adversity. Who can tell me why this is different than all of the questions we've done so far today? Nope. Be careful. This is different than the ones we've done. Abby, do you know? This doesn't factor down. If it was plus 1 at the end, it would. So, what happens if we can't factor this? What happens if we can't factor? We throw it, we'll say, are you going to throw your pencil at the wall and start crying? No. Try not to. It's very awkward when people start crying in class. What do you want to do? Quadratic formula is probably or completing the square. It doesn't matter which one. Well, what do you want to do? Completing the square or quadratic formula? Make a decision. Completing the square. I like that. I like that. You know why? Because you're going to have to use it later. Could you do quad formula? Sure. Complete the square. So when I do that, I want to, here's my equation. I've got x squared minus 2x minus 1 equals 0. To complete the square, I need the first two terms alone. Why does this set up nicely to complete the square on? Hands up, please, if you can tell me why this sets up nicely. Go ahead. Yeah, but I look at the original. What's your a value? 1. And look at your second term. What if that was a 3? Could you complete this, or would you do completing square with that? Why? It'd be, you take half, you starting with fractions in it. So now, looking at what's there, let's take half of our b value, which is -1, square it, which is 1, and we're going to add that to both sides. What would you do next? Catherine, do you remember? What does the left side factor down to? You recall? No, because it couldn't get loop. Oh, minus 1. Yeah, this one, we're talking about this one right here. Take half of that value. This up here can drop right in that spot. What's the next step? Maddie? You can tell me what we would do from here. Oh, what do you say? Louder. Take the square root. Yeah, we're going to take the square root of both sides now, and this is where I hope we don't make a mistake. Boy, I hope we don't make a mistake. Abby, are you mad at me right now? Not really. I don't elicit any emotion? Then never mind. Who's mad? Who's mad as Helen isn't going to take it anymore? 3 people? God. Come on. Are you going to throw a desk at me? Is that fair to say? Okay, fine. I want somebody who's so mad they're going to throw a desk. What? That's the kind of emotion I hope we bring out. I want you to hate me with passion. Don't just hate me. Hate me a lot. Now, what do we do to solve for our x? So what's your answer? This is an exact answer. We were told before we're going to do an approximation. So go into your calculators and give me that approximation. There's 2 of them there. To the, did we say hundredths position? We've been going 2 spots?
Yes.
Okay, hundredths position, hands up when you can tell me one of them. Just one. What? 2.14? Okay. Is that what we got? 4-1. Sorry. What's the second one going to be then? Hands up, please, and you can tell me what our second one's going to be. What? Can you check that using n solve? Sure. Next one up. By the way, why would that not give you the answer if you did n solve? I'm sorry. You can check by plugging in. Why is n solve not going to give you the right answer? It's only going to give you 1. This question up here shows me how much, if you didn't do well before, how much you're actually invested in doing well. Take a look at what's there. You tell me what's the first thing you're writing out on this next question. You got 1. That's not good. 1. Woo. That makes me think those grades were exactly what they should have been. John Paul, what do you want to say? There you go. What let you know you're using the PERT formula? What did it say? Now I'm going to make my replacement in the interest of finishing this on time. We're going to end with 2,500. We're going to start with 2,000. We've got e to the 0.02 t power. You're solving for t. This is what you're trying to isolate. What needs to happen in order to isolate this? 1 person. 2. Eli, what do you say? If I go sides by 2,000, this would come out to be 5 over 4 or 1.25. It doesn't matter which one you do. 5 over 4 is equal to e to the 0.02 t power. What do I do from here? What do I do from here? Really? What? Yep. Nope. I don't need to do anything with the power or compute that out. You could, but it's just you're still gonna have to do something afterwards. What?
You're gonna do t equals.
Let's put it in log form or natural log form and divide both sides by 0.02. Hands up, please, when you can tell me what that t value is going to be to the hundredths position. Put it in log form and evaluate it out. We've got no takers, really? Really? 1? Come on. Jessica, what do you think? 1.6, you said? Okay, do we agree? Yes or no? You could check your answer by using an n solve on it. Check your answer by using an n solve. Now, as far as what your homework is, if I'm you, I go do any 5 from here, and I'm going to do these 3. By the way, take a look, read 51. Why is there that little caveat in question D? Because there's always going to be some wise guy in every group. Read question 51. Why did they threw something in there for D? And you sit there and go, oh, these people, they're so difficult. You'll probably already know why. What? More than that. I have some people who make this stupid point. What? There's going to be one. There's always one in every group. Goes, well, wait a minute. Some years got 366 things. Dumb. Really? Really? That's what I'm saying. The interest is only compounded during leap years. Maybe we'll do that on a test to see if you get it. Bob leaves his money in an account in 2016, and 2016 is a leap year. Interest is compounded daily. How much more would he have if he did it in 2016 than if he did it in 2015? Boy, I just wrote a great question. I'm calling the state right now to tell him that. And he's right underneath it, Bob's a moron. Stop being difficult, Bob. Have a great rest of your day, loves.